All right, this is one of the coolest topics we'll cover. And by cool, I mean fun, but also kind of difficult. Pascal's triangle. You may have seen this before, you may not have. It starts with a 1. Then the next row goes 1, 1. Okay, now we can actually make the next row properly. So it's 1s on the outside. And then to get the number in the middle, you add the 2 above it. So you get a 2, because 1 plus 1 is 2, believe it or not. And then you keep going. So 1, 1 on the outside. 1 and 2 give you 3. And 1 and 2 give you 3. And then next row, 1, 1 on the outside. 1 and 3 give you 4. And then we got 6 and then 4. Keep going. 1, 5, 10, 10, 5, 1. And you literally just can keep doing this. 15, 20, 15, 6, 1. It goes on forever. Pascal spent a long time doing this. We call this row 0. And we call this row 1. And we call this row 2. And we call this one row 3. It's really easy to tell which row is which because row 3 has a 3 there. Row 4 has a 4 there, for example, and etc, etc. Okay, now let's talk about something completely unrelated, combinations. C40. So we talked about this in the last video, but just as like a little example, C43 was 4 factorial on the top. 3 factorial and 1 factorial there. Turns out that gives you 4 when you work it out. Now, we can do combinations on the calculator, which are a lot quicker. So if you go like your normal calculator menu looks like this, you got the option button across to probability. We're going to do 4 NCR 0. So 4C0 is 1. Next, 4C1 is 4. Next, 4C2 is 6. And then the next one's 4, and then the next one is 1. Interesting. Where have I seen 1, 4, 6, 4, and 1 before? Oh my goodness, it's Pascal's triangle. Who would have thought? So yeah, row 4 is that one. And if I wanted like this thing here, that would be C42, the 4th row and the second number. And by the way, the first number I count as 0. So that's C40 gives you that one. C41 gives you that one. C42 gives you that one. C43 gives you that one, and C44 gives you the last one. If I wanted like that number here, for example, this would be C62 should give me 15 because it's the second number. If this one counts as number 0 in row 6. And we can check. So if I go 6C2, oh my goodness, it's 15. Wow. Pascal is definitely onto something. All right, now let's talk about something completely unrelated, binomial expansion. A plus B squared. We do know a formula for this. We expect it to be A squared plus 2AB plus B squared. Where that comes from is because you're foiling it out. So you're going to get A squared for the first bit. You're going to get AB for the next bit. BA for the next bit, and then B squared for the last bit. The AB and BA combine to give you 2AB. Interesting. A plus B cubed. Okay. So a little cheeky way we can deal with this is we can actually write this as A plus B squared times A plus B. So that's A squared plus 2AB plus B squared, which we worked out just before, times A plus B. And I'm going to FOIL this one out. So it's A cubed for the first term. It's A squared B for the next term. It's 2A squared B for the next term. And that's just getting the middle ones there. And then what is it? 2AB squared. Next one, B squared A, but I'm going to keep it in alphabetical order. So AB squared. And last one, B cubed. Really important you keep stuff in alphabetical order. It helps you spot like terms. Speaking of like terms, we can spot some. So A squared B and 2A squared B give me 3A squared B. AB squared and AB squared give me 3AB squared. And A cubed is A cubed. And B cubed is B cubed. Oh my goodness. All right. I'm not going to put you through watching me do a plus b to the power of 5, but I will tell you what it is. It is a to the 5 plus 5a4b plus 10a cubed b squared plus 10a squared b cubed plus 5ab 4 plus b to the 5. Give me any power on there and I could write out the expansion for you, and no, I didn't just remember all the formulas. There is a pattern to it. I would really encourage you to see, based on this one, the cubes, and the 5s, if you could pause the video and spot the pattern. What's happening? Okay, now that you've paused the video and had a good think about it, I'll tell you what's happening. The powers of A decrease. I'm hoping that pattern's not too bad. 5, 4, 3, 2, 1, and gone on the powers of A. The powers of B increase. Who would have thought? So nothing. 1, 2, 3, 4, 5. Oh my goodness, they're increasing. And the coefficients are the nasty one. But Pascal is definitely onto something because it's from Pascal's triangle. So the coefficients: 1, 5, 10, 10, 5, 1. Hey, that looks like row 5. 1, 5, 10, 10, 5, 1. Wow, okay. So if we wanted something like one that we haven't done yet, a plus b to the power of 4. So I can write this out by dropping my powers of a4, a cubed, a squared, a, and gone. I can raise up my powers of b, so b, b squared, b cubed, and b to the 4. And then the coefficients come out from Pascal's triangle, so 1, 4, 6, 4, 1. So 1 lot of a4, 4 lots of that, 6 lots of that, 4 lots of that, and 1 lot of b4. And that's the full expansion of a plus b to the 4. No working out. There it is. Done. So, by the way, if you were just, if you had to expand out a really big one, to save you writing out Pascal's triangle, you could use this little combination trick to do it. So, for example, this number here would be C51, C52, and it just saves you writing out the whole triangle: C53, C54, and C55. And I guess the first one's C50 technically. Groovy. All right. Now, how do we expand something like this? Well, I'm going to just write out the formula for a plus b cubed first. So remember, the powers of a drop, the powers of b go up. If you want a little trick to make sure that you're always in line, the powers should always add up to this number. So that would be like 3 plus nothing gives you 3, 2 plus 1 gives you 3, 1 plus 2 gives you 3, and then 3 plus nothing gives you 3. So we know we've done that bit, right? The coefficients come off Pascal's triangle, so it's 3's in the middle and then 1's on the outside. And I need to say that 3x is A and 2 is B. So we can just line up what we're doing to the formula above. So it's going to be 3x cubed. We're going to get 3x squared times 2. 3x times 2 squared and 2 cubed. I like to just bracket everything so I know I haven't done anything wrong. 3x cubed is 27x cubed. You have to make sure that you cube the 3 as well. This one here, let's see, is 27 times 2, so that'll be 54x squared. 3 times 3 is 9, times that by 4, so you get 36x. And 2 cubed is 8. Done.